We're going to look now at another group of possible transformations, just to give you one more idea of what a group is. We take the transformation, these are called permutations. We take the numbers 1, 2, 3. We start with the number 1, 2, 3 to define every one of these permutations. The permutation A star is going to be defined as the permutation that takes 1, 2, 3 to the order 2, 3, 1. A permutation of three things is a different ordering, or a reordering of those three things. So the reordering will be to take the first, second, and third objects, whatever they might be, and move the first object to the last position, the second object to the first position, and the third object to the middle position. Now we illustrate that with the following picture. The first object, actually the picture's wrong. The first object will go to the third position, so that's like going from here to here. First object to the third position. The third object will move to the second position, and the second object to the first position. So I've got these arrows wrong. And let me just white those out and change this. Okay, third object goes to the second position. The second object goes to the first position. Okay, third object goes to the second position, second to the first position, and of course the first to the third position. Now, the second one, the first object goes to the second position, and the second object goes to the first position, while the third object remains in the same place. That's illustrated where we see the switching of the first and second object. And we'll just do a little circle here, little circular arrow showing that the third object stays where it is. In this transformation, everything stays where it is. We get the three little circles. Okay, now in this transformation, let's see, 1, 2, 3 goes to 1, 3, 2. How would we draw that? First object goes to the first position, so it just stays where it is. The second and third objects switch positions. So we have this. And for this transformation, the first object goes to the second position. The second object goes to the third position. So let's see, first object goes to the second position. Second object goes to the third position. And then the third object will go to the I drew that wrong. First object goes to the third position. Second object goes to the first position. I must have been looking up here or something, I don't know. Let's see. So let's correct that. Okay, first object goes to the third position, which would be an arrow. It takes the first object all the way to the third position here. And this is going to end up a real mess. The second object goes to the first position. So the arrow goes from the second object to the first position. And then the third object goes to the second position, so that this third object here will have to come back to the second position, and we'll draw the arrow there. Excuse the confusion. I don't have the best visual. I can't see the diagram that well. Okay, just because of obstacles. No excuse. Then this last transition, we see that the first object goes to the third position, the third object to the first position, so we have the arrow that indicates the switching of those two objects, and the second object stays where it is, and I'm not going to bother with the little circle here. We name these transformations A star, B star, C star, D star, A star, and F star. And again, these are the 6 permutations of 3 objects. These are the only 6 ways that we can change the order of the objects 1, 2, 3. And of course there is the one transformation that doesn't actually change it, but we've got to include that. And of course that's going to be an identity element when we make a table for the transformation. If we want to prove a couple of things, let's see if B star F star equals A star. Now let's see, B star is the transformation whose picture we see here. It switches the first and second objects and leaves the third unchanged. So for B star, I'm going to draw a picture of what that does. That takes the 1, 2, 3 objects and switches 1 and 2 and leaves the third the same. And then what does F star do? Well, we can see F star here. It's the one that switches the first object and the third. So it has a picture that looks like this. Now if we start with 1, 2, 3 and do this switch, what do we end up with? Well, we end up with 2, 1, 3. So that 1, 2, 3 gives us 2, 1, 3. And that's what we get if we apply B star to the 1, 2, 3. If we then apply F star to the 2, 1, 3, that's going to switch the 3 and the 2. And we're going to end up with 3, 1, 2. Now what transformation is the 3, 1, 2? Okay, well that's what E star does to the 1, 2, 3. In other words, if we'd started with the B star transformation and then done the F star transformation, we would have gotten the E star transformation. And for some reason I'm calling that the A star transformation, so I'm going to have to change that to an E. So we apply B star to this one, we apply F star to the result, and what we get is the same as if we'd applied E star to the original. Let's see if D star and E star actually give us F star. The way things are going here, I'll be surprised if it does. The D star is this transformation that switches the 2 and the 3. So let's draw a picture of a transformation that switches the 2 and the 3. And then the E star is the one that effectively moves everything to the left. 3 goes to 2, 2 goes to 1, 1 doesn't have any place to go, so it's got to go over to the other end. So this transformation is going to have this kind of a diagram. Now if we start by doing D star to the 1, 2, 3, that gives us 1, 3, 2. And then if we do F star to that transformation, what's that give us? Well, we're going to switch the 2 over to the next position, the 3 will go over, and the 1 will go here. So we're going to end up with 3, 2, 1. And 3, 2, 1 is indeed what F star does. So, we do get a group if we make a table for all possible transformations A through F. We do get a group when we apply these transformations. The permutation transformations do indeed give us a group.